Welcome to The Explainer. Have you ever looked out at a sprawling field of crops and just wondered how on earth they survive the absolute gauntlet of microscopic threats out there every single day? We usually think of plants as helpless, right? Like they're basically just sitting targets waiting for a disease to strike unless we step in and spray them with chemicals. But it turns out nature has a much more sophisticated strategy. Okay, let's dive right into this fascinating, completely invisible world hidden inside our crops. Today, we're exploring some truly groundbreaking research that reveals a hidden layer of defense, one that could literally change how we grow food forever.
So I want you to imagine something for a second. What if, instead of relying solely on external armor or all those chemical sprays, our global food supply had its own secret, built-in defense system? We're talking about a microscopic security detail operating completely silently in the background, 24 hours a day, 7 days a week. It honestly sounds a bit like science fiction, doesn't it? But, as we're about to see, it is entirely real, and it is happening right beneath our noses.
To really wrap our heads around this, we first need to define the main character of today's explainer, the endophyte. So an endophyte is any organism, like a bacteria or a fungus, that lives its entire life inside plant tissues, without causing any apparent harm to the plant itself. Unlike parasites that just drain a plant's energy, or those surface-level molds that cause rot, these hidden heroes are tucked away harmlessly inside the roots, the stems, and the leaves. Think of them like quiet tenants living inside a high-rise building. And, as scientists are now discovering, these tenants often pay their rent by fiercely protecting the whole building.
Part 1. Hunting for Fungal Heroes.
To track down these microscopic defenders, a team of researchers went on an incredible scientific hunt inside oilseed rape plants in central China. Now, oilseed rape is a massive, economically vital crop worldwide. It's used for everything from cooking oil to biofuel, but it is notoriously vulnerable to disease. So scientists wanted to know who exactly is already living inside these plants and can they actually help? They didn't just casually peek through a microscope. They mapped out a rigorous scientific detective story. They took completely healthy oilseed rape plants, carefully surface sterilized them so there were zero outside contaminants, and then systematically chopped up the internal roots, stems, and leaves. They put these tiny pieces in petri dishes just to see what fungi would grow out of the tissues. From there, they pitted whatever they found against devastating plant pathogens to see which ones would act as true protectors.
And wow, the sheer diversity of what they found inside these completely normal, healthy-looking plants is just staggering. They discovered a total of 97 different endophytic fungal isolates. Just look at how this breaks down. The stems are actually the most crowded hiding spot, housing 49 of these isolates. The roots held 35, and the leaves contain 13. All told, they identified 40 distinct species of fungi quietly living inside this single crop. It is literally a microscopic jungle inside every plant. But the big question was still hanging out there. Were these fungi just freeloaders or were they fighters?
Section 2. Fungi versus Plant Pathogens. Welcome to the Fight Club.
To see who would actually win in a head-to-head battle, researchers set up a high-stakes microscopic fight club. On one side of the arena, we have the ultimate threat, Sclerotinia sclerotiroideum. This is a devastating pathogen responsible for stem rot, a disease that brutally decimates oilseed rape and tons of other crops worldwide, costing farmers millions. On the other side, we have our defense. Out of the 97 isolates the scientists found, 24 specific endophytes stepped up to the plate. When placed in the exact same petri dish as that deadly pathogen, these 24 heroes literally drew a line in the sand, creating visible zones where the pathogen simply could not cross. No way, no how.
But hey, in science, winning in a petri dish isn't quite enough. You have to test it on the actual plant. So the researchers took the chemical filtrates, essentially the protective juices produced by these fungi, sprayed them right onto real oilseed rape leaves, and then deliberately infected those leaves with the stem rot pathogen. And that brings us to the final 4 defenders. These 4 specific fungal isolates, Aspergillus flavipes, Chaetomium globosum, Clonostachys rosea, and Leptosphaeria biglobosa, were absolute champions. Without them, the pathogen chewed massive 55mm rotting lesions straight into the leaves. But when protected by the filtrates of these 4 endophytes, the damage was completely crushed. Those massive lesions shrank down to nearly 0 millimeters. The leaves just stayed healthy. Unbelievable, right?
Moving on to Section 3. Invisible chemical weapons. This is where things get really wild.
Fighting face-to-face is one thing, but what if you didn't even have to touch your enemy to completely defeat them? The researchers had a hunch that some of these fungi might be emitting defensive gases. These are called volatile organic compounds, or VOCs, which means these hidden bodyguards are essentially walking around equipped with invisible chemical weapons. They can stop an infection from a distance just by releasing a very specific blend of gases into the surrounding air.
To prove this was happening, they set up this incredibly clever double-dish experiment. In the bottom dish, they grew an endophytic fungus. In the top dish, facing upside down, they grew the deadly stem rot pathogen. The two fungi never physically touched each other, not even once. They only shared the trapped air inside the sealed dishes. Well, it turns out the isolate, known as Fusarium oxysporum canr 46, used its invisible VOC gases to completely stunt the pathogen on the top plate. It actually inhibited the pathogen's growth by a staggering 94.5%. Basically, just by breathing out, this endophyte completely neutralized the threat.
And the scientists didn't stop there. They took this a step further with what I like to call the tomato test. They wanted to see if these invisible gases could actually protect harvested food sitting on a shelf. So they took fresh cherry tomatoes, deliberately wounded them, and introduced Botrytis cinerea, a notorious fungus that causes gray mold. The defenseless tomatoes quickly succumbed to this fuzzy, gross gray rot with lesions growing up to 21.7 millimeters. But the tomatoes that were placed in a sealed container sharing air with our hero fungus, canr 46, the fungal gas completely saved them, slashing that soft rot down to just 8 millimeters and completely stopping that fuzzy mold from taking over. Saved by a gas?
Section 4. Boosting crop growth.
Now, you might be thinking, protection is their only job. Well, the job description for these fungi goes way beyond just security. They actually act as personal trainers to actively boost the plant's health. When researchers soaked oilseed rape seeds in a liquid containing spores from specific endophytes, the results blew them away. Treating seeds with one specific isolate, canr 71R, actually increased the single plant dry biomass by a massive 187% compared to the untreated group. 187%! The fungus was actively promoting rapid, robust growth from the inside out.
And finally, Section 5. The future of farming.
So, what does this all mean for us? Why does it matter? Well, it represents a total paradigm shift. For decades, traditional farming has relied incredibly heavily on spraying synthetic chemical fungicides on the outside of crops just to keep them alive. But this research proves that we can actually isolate diverse, natural protectors that have already evolved over millions of years to live harmoniously inside the plants. By harnessing specific fungi like Aspergillus flavipes, Clonostachys rosea, or that gas-emitting Fusarium oxysporum, we could completely revolutionize how we boost crop yields and fight rot, and we could do it without relying on harsh chemicals that damage our environment. Which leads us to a really fascinating, profound thought to close out today's explainer. What if the future of agriculture doesn't rely on adding more external chemicals, but on unlocking the invisible heroes already living inside the plants? By understanding and basically partnering with these hidden bodyguards, we might just secure our global food supply in a way that actually works alongside nature rather than constantly fighting against it. Thanks so much for joining me to explore this incredible invisible world. See you next time.